So happy Thursday and good afternoon, everybody. My name is Rob Romanowski. I'm the Director of Sales Operations with 3HTI. In our webinar today, we're going to look at the Creo Flow analysis extension for Creo. We're also going to look at I believe there's 3 different variations of this product, Paul. Something tells me there might be 4, but I know there's at least 3 different variations of this product, which is really good because if there's certain features or capabilities that you don't need, you don't have to pay more for it for a higher end package. And I know with there's some CFD packages out there that, you know, it's either all or nothing pretty much. Like you get the whole software program, and if you don't use a good portion of it, then you're still stuck with the whole thing. But with this, there's definitely different capabilities within the 3 different extension offers, and we'll go through that today as well. So if you have any questions, put those in the question and answer box, and we'll try to get to them as we go along, but we'll definitely answer them at the end. So without any further ado, I'm going to have Paul Dye. Paul's a solutions consultant with PTC and an applications engineer at their Virtual Center of Excellence. Paul is no stranger to our Thursday webinars, so he does a great job all the time. So no pressure today, Paul.
Absolutely. No, thank you very much, Rob, for having me on. Thank you
Absolutely
for jumping on as well. This is probably, no bias, but I think this is probably my favorite extension in Creo. I think it's extremely powerful. I mean, and in terms of value, there's really no beating it. And no bias as well. I think 3HTI is probably the best partner that you could possibly have for working with flow analysis as well. Some of their internal resources are just phenomenal for being able to support what we do from the simulation side. So really happy to go through and explain a little bit more into this. Happy to walk through exactly what we're talking about whenever we say flow analysis from within Creo. So if you have any questions, feel free to drop those in. I can go through and answer on any of those. If there's anything that I can't answer today, and I have an extensive team that I can reach out to get pretty much anything that you need answered as well. So feel free to drop that in the chat and we can address those as we go along here. So first thing I like to do whenever we go through and speak to anything analysis related really is speak to the challenges that we typically see out in the industry, especially around computational fluid dynamics, flow analysis, CFD, any way that you might say it. It's really typically seen as something that would require extensive training or knowledge that your designers, your engineers in general tend to lack. And it's something that to even run this type of analysis, it typically requires the use of third-party tools that are oftentimes not only very expensive to end up even being able to get to work with, but can be hard to use. It's because you have to take your models out of your CAD environment. You have to be able to export them out, have somebody that has knowledge on how to use fluid dynamics tools to even begin into analysis. So as you can imagine, that process is very time consuming from start to finish. It tends to make the process really only viable at the later stages of the design process, because whenever you're more so in the early to mid to development stages, your models are constantly changing. You simply just can't wait around for analysis results to come back because your model more than likely has already changed by that point. What we tend to see is that leads to, first and foremost, an over-reliance on physical prototyping, because you still need a way to verify that your design is going to work correctly, that you're not going to have issues whenever it goes out for production. And that, again, tends to occur later in the development cycle. It could be very costly if you need to go through multiple iterations of prototypes in order to prove that out. And that reliance causes projects to be delayed, causes them to come in over budget. Obviously, things that we need to be able to avoid in our projects and ultimately in the products that we develop. And these are all challenges that we set out to solve with the flow analysis extension in Creo. The goal of this extension is to take those fluid dynamics capabilities, which typically have a higher bar to entry, and we're just simply putting them into an easy to use tool right within the CAD environment and moving away from a heavy reliance on late stage prototypes or other verification techniques. We're making this part of your early stage design process. And we want to get those results back early and often and in a way that's easy to use for our Creo designers. And that's one of the biggest things around this is, even though it is a higher end package and really has high end capabilities, we first and foremost made it in a way that works well for your Creo users. It's working within that same familiar user interface, and it's meant to be user friendly. We want both the analysts and as well the standard Creo user to be able to work with this extension. We have wizards built into the tool to help you get started and help you through the process of setup. And it's all built into the overall process of what we do from a design perspective. And that's one big thing here as well, is the fact that the design and the flow analysis work that you do in Creo, working between the two is seamless compared to your normal process of working with a third-party system where you could have issues translating, switching between your CAD and analysis environments. We don't have to worry about that. We've broken down the barrier between those two different worlds, between design and analysis, and are working more within one unified analysis-driven design environment. And as you'll see, whenever I go through and build these simulation studies out, the flow model creation is very straightforward. So for example, you have the ability to tell the system to automatically generate the mesh for the analysis. You, the user, don't have to go through and define all that yourself. You still do have the ability to have more manual control over the process in areas that you might like to. But if it's easy and it's something that you want to have built out for you, that's something that is right there done for you. And really, again, making that overall creation of the simulation studies as fast as possible. And then whenever it's time to run the analysis, just as fast for getting the simulation results. You don't have to ship off a model and hope to get results back in hours or someone to send it back to you by the end of the week. You just are able to go through, run the analysis yourself, and get those results back in a manner that's much faster. And one of the things as well, in conjunction with that speed, is the results that we're getting back are extremely accurate. We have many different ways of viewing those results. You can take different screenshots of the model, create XY plots, view the ISO surfaces like you can see on the screen now. And with that, you're not only getting results back, but getting insight into the process as well. You're understanding exactly how well your models are performing. So it's not just as a way of looking at it from a pass or fail perspective. You're getting those results back, and then right from there, go back and turn that into what you do from a design perspective. Improve the model so you're ultimately ending up with a part that not only just passes, but it's going to be much more improved and going to be a better design overall after you go through that. Now, again, what we really wanted to do here with flow analysis in Creo is lower the bar to entry and make sure that we offer packages in a way that allows you to not have to, completely break the bank in order to get started into what you might need for your process. So we've broken it up into three main areas. We have first and foremost our standard flow analysis tool. If you're focused on simply just the flow, looking into things such as heat transfer, turbulence, you can see here that the base flow analysis is going to be your best bet. It really gives you a ton of functionality to cover what you would need in your standard types of flow analysis and begin to understand how those systems are working. Now, from there, if you wanted to analyze elements such as individual particles or looking into radiation, you might want to move up to the second plus package. It gives you the ability to simulate the movement of individual components. You can animate on the analysis, even while it's being run, and start to really add some comprehensive capabilities here. So if you need to start to bump up the capabilities, you have that. And then if you want the full scope of what we're able to work into here, you have what's available in the premium. And this is starting to really expand upon those capabilities for cavitation, multi-phase, multi-component, dynamic style studies. If you really need to understand in full how your simulation studies are running, how they're going to look in the real world, and take into account all those different capabilities, we have the tools to get you there. So matching up with all those different use cases that you'd potentially like to study. You can see a bit of a breakdown of what this looks like as well. And I'm going to go through and show exactly what this looks like from within the context of Creo. But one thing that I'll mention that is that this tool is built out through one of our partners, Simerix. They provide the engine for this tool, an extremely talented team that goes through and builds out this tool and is constantly making improvements to this as well. So that's one thing to note, is that with every single release that we see of Creo, it's amazing how much more improvements that they're making to the tool with every single release. So even with Creo 9 that just came out, we had a lot of enhancements. With Creo 10 coming, even more enhancements coming within there as well. So if you ever wanted to see some of the things that they're working on, you could go to simerix.com, SIMERICS.com, and they have a lot of different examples that you'd be able to work through there. And I'll leave this up for a second, so take a pause here to see if there's any questions. If you haven't put any questions in the chat, feel free to drop those in now. But I'll give a brief moment here before we hop into the demonstration. I'll pause and see if we have any questions.
No questions at this time, Paul.
Awesome. Yeah, so I can move into here looking at a brief demonstration so we can see a little bit about what that workflow would look like for diving into a flow analysis study here from within Creo. And I'm going to be working with our Polaris snowmobile data set. More specifically, we need to get some more information onto our heat exchanger that we have working inside here. We can go ahead and open up this part so we can get to work. And you can see that we have some good geometry that we'll be able to utilize for the study. In my case, I know that I'm going to have water moving through that heat exchanger, so we can go through here and work through the process of getting that set up. Now, the first step, if you wanted to get started into this, is just by simply jumping up into the Applications tab and selecting your flow analysis study. All right, and with that open, we'll go ahead and jump into a new project, and first and foremost, lay out our fluid domain for the study. The fluid domain is going to be essentially the boundary for the simulation. It means that all the fluids that are within that study are going to be contained within this 3D space. Another thing that we can do here as well is lay out surface sets that are telling our study where the openings are located. In other words, where the fluid is either entering or leaving the system. And after we have our fluid domain, there's obviously parts of the model where fluid will not be flowing through. So here we're just telling the system which parts of the model should be treated as solids and then excluded from the study. We're then able to define our different materials for the study as well. So this includes both our fluid domains, which we can go through and work with here and change for whatever we need. You can see we have a lot of different options here. And in my case, I'm likely just going to be working with water because that's what's going to be working through my system. We have a lot of the out of the box options for those fluid materials. And then you always go through and have user defined materials there as well. And then from a solid model perspective, it's going to work with the same solid material library that we've always had from within Creo. In our case, we'll leave that as aluminum. And after we have our materials laid out, next piece would be to decide what we want to run for our particular study. So what this is allowing us to do is really decide exactly what we want to focus on whenever we go to run the study. We don't have to go through and simulate every single type of use case if it wouldn't be particularly useful for our study. So maybe in my case, I know that I'm interested in turbulence for our model. We're also interested in getting heat and streamlines. And so anything that we're not interested in, we don't have to spend time running calculations for those and really focusing in just specifically on the areas that we're concerned with. After that, we'll take a closer look into some of the conditions for our analysis. For our study here, we want to see first and foremost what our minimum and maximum temperature values are going to be. We also have options to plot those outputs. I'll touch more on that in just a minute. Now, the next spot that I want to take a look at here is going to be around our boundary conditions. So first and foremost, let's check out our inlet pipe. We can go through and enter different values that we want to observe. In my case, I want to look at the inlet flux and the temperature. And as you can see, there's many different parameters that I can go through and change here. It's really tailoring the analysis to the exact case that I want to study. Let's go ahead and do the same thing down here at the outlet. In my case, I'm pretty much happy with the values that are currently set there. Looking at this from an overall perspective, we know the exchange coefficient, we know the ambient temperature for our particular heat exchanger. So we can go through very quickly and have those values defined for our exchanger. And once we have that all added in, we can then simply have Creo define the mesh for our fluid flow analysis. Creo is automatically able to build that out for us. And we can simply just go through and observe to make sure that everything is looking good there. So let's visualize what that mesh looks like here. And looking at the mesh here, you can see that in some of the flatter areas where there's a little bit less complexity, what the mesh has done is spread out that element size and made it a bit bigger because it's easier, less complexity. And in any of the areas where there's a little bit more curvature, a little bit more complexity involved, it's gone through and made each of those individual elements a bit smaller. So again, that's an area that you can have some manual control over, but in 99% of use cases, it's really going to be able to do that automatically there for us. I'll take a moment here to see any questions on this so far, anything that we could answer around this.
Well, we got a few. So one question is, well, the first question is does this work as a standalone product, or does it have to be a standalone application that could work maybe with another software, or this works with just Creo?
This works with just Creo. This is out of the box Creo extension. or it's not out of the box capabilities, but it is an extension that would require the use of Creo Parametric to use.
So another question is, what releases of Creo will this work with?
It has been in Creo for quite a while now. So if you're on any of the modern releases of Creo dating back to maybe Creo 4, I'd say you should be good to go. And if you're not on Creo 4, you should get up to Creo 4 and beyond at the very least.
Yes, I would agree.
And I see the other one is linked to the CFD provider. I can go ahead and drop a link into the chat here.
Okay.
Let me go ahead and get that for you here. Simerix is the provider of that engine. Let me go ahead and drop that into the chat here for you. And that'll provide a link that you could go through and look at for the engine that we use here in Creo.
Simerix.com. All right.
All right.
Well, thanks for engaging, everybody.
Yeah.
That's it for now.
Awesome. Yeah. And again, if there's anything that comes up while we run through the study here, feel free to drop that in as well.
Cool.
All right. We'll turn off that mesh visualization for now, and we can go ahead and look at our plots, and let's start to run this. And what you could see is essentially as soon as I click the button to run the simulation, you're immediately getting data back from the study. And with that, you're able to make changes to the animation style, go ahead and put it into a form that's going to best display the information that you want to see for that study. You can see looking at our plot information at the bottom, the maximum temperature is settling out just around 360 degrees Kelvin. And you can see that for each iteration that the study is going through, your plot information will be updated real time. And look at that, it took us less than 3 minutes to get that set up, and we're getting results back just that fast. And it's very easy to go through and see from a visual perspective what we're getting back there. All right, looking at our model here, you see that water's coming into the heat exchanger at its highest temperature, and as it's moving through, it's cooling down by the time that it gets to that outlet, so everything seems to be working as intended. You could switch to look at some other outputs like pressure here to see how that's changing over the course of the flow. Maybe you need to see the effect of temperature on the outer casing. That gives us some very good insight as well, gives us a better understanding of exactly what's happening in that process. One of the other useful tools that we have is the ability to take section views of these different results. So say we want to take a look at temperature values inside the model, let's move around to the X plane, the Y, the Z, really understanding how that's affecting the model in many different areas. Another powerful tool that we could work with here is the ability to search for specific values throughout that simulation. We first have a slider bar that we can move around from a minimum to a maximum to see where those values are located. Also, if you wanted to see a particular value, say 345 degrees Kelvin, we could just simply type that in and see exactly right in the model where that would be located. All right, well, from this point, what would typically happen is someone from my team, because we're working at this throughout the design process, we might get sent over a new version of the model that we're working with. Because as I mentioned, we're likely using this throughout the development of our parts and assemblies. This version has more of a lattice type structure. It's definitely going to change how that heat exchanger is going to work. And now, instead of us having to go through and set up an entirely new study, what we could simply do is just open up the one that we had before, utilize the one that we had created from the previous example, and we'll just update the study to recognize some of the new geometry that we added into the model. We'll also update those surface sets there to include the faces on both the inlet and the outlet for the flow. And finally, we can go ahead and hide those CAD bodies. We'll just utilize the mesh that we have here in the plots that we had set up from before and run back through that analysis. Right. And again, as soon as we click to run the analysis, we're instantly getting meaningful data back from the study. And we could again go through and change any of the properties to get our flow into a form that makes the most sense. And looking at the animation for that flow model there, it's definitely going to be making a difference in terms of how that direction of the flow is moving. It's probably spread out that temperature gradient a bit there. And looking at the plot information, it's beginning to converge towards answers as it's going through multiple more iterations, and it'll run through those until it gets back to a convergence, whatever we've set for it. All right. And
We
with
had a
that complete,
question
yeah.
asking about expansion and contradiction.
Oh yeah. Anything specific on that?
No, it just says, what about expansion and contradiction?
I believe that would actually be covered within the base of the flow analysis model. I have to check into that specifically to see where that might lie, but that
Okay.
would probably be something that would be covered from within the base for expansion or contraction. I have to look a little bit deeper into that one.
Okay.
Yeah, but again, really the main idea here is once you go through and make those changes, be able to understand exactly what it's doing to the model here. So we can understand what it's doing from a temperature perspective, where exactly our flow is reaching, what that effect is. Here we're able to spread out the stress values, or not the stress values, the temperature values much more cleanly throughout the model here. And whatever you need to look through and find here, very easy to do so as well. So very interactive and something that we want you to be able to get up to speed with as soon as possible and really be getting results back just that fast. All right. So again, if you have any questions, feel free to drop those in. But again, there's a ton of value to be able to work with that throughout the process. So really wanted to go through and just show a general example of what we'd be able to do there from within the process. But like I mentioned, feel free to jump into the link that I provided to see some of the different areas that Cimerix has played into. We've really covered a lot of different use cases and worked with tons of different companies in the industry for these types of simulation capabilities. And like I mentioned earlier, 3HTI is really the best that you have for partnering up and getting these types of studies into your own current processes. So I can pass it over to you, Rob, to expand a little bit on that. And if we have any other questions, feel free to ask those as well.
I will I will wholeheartedly agree with you, Paul. One of the reasons, why we're so good at finite element analysis and CFD is because on our staff we have a gentleman by the name of Bill Stickney, who was a customer of ours when he worked at Laird, and then decided to come on board with us at 3HTI. And Bill is familiar with a whole wide range of FEA and CFD solutions. He's seen a lot. He's done a lot. He's worked with several of the national laboratories. He's worked with several of the different NASA space centers. He's done training on Creo Simulate for NASA. So he's a pretty sharp guy. He knows his stuff, has seen a lot, knows a lot of other softwares like the Simulia suite from Dassault. He's very familiar with Abacus. He's very familiar with Nastran and with the ANSYS tools. So that allows us to help our clients who may not need to purchase the software, but have a special project that they want to get done. So they can we can work with them, do the project for them. And that way they don't need to buy the software if they're not going to use it that often. Or if you have projects that are going to be upcoming and you need to purchase the software, we can also work alongside of you to help your team learn how to use the software specifically to what you need it to do, and be there as a partner to help get you help get your team and get your people up and running and understanding the software as quickly as possible. Because if software is great, but it's only as great as how quickly your team can become proficient at it, so you can start to see a return on the investment. And that's what our goal is, to help our clients get proficient at it very quickly. So a question that came in says, does the package have the ability to analyze porous media?
Yes, it does. I can drop another link into chat here that provides a couple how-to videos that would show a few different examples that you could walk through here as well. There you go. This would be in our PTC
Cool.
community tab, so you could look at a couple of examples there. Should be able to touch on that. But yes, that is a capability as well.
You're good, Paul.
I told you this is my favorite extension in Creo. It's really awesome.
I can see why. So I guess that's going to be it. Is that going to conclude what you're presenting today, Paul?
Yep, everything from my side.
All right, cool. So if you have any questions, or even if you want to see a more detailed demonstration, you can respond to the email that I sent, the email invitation for this webinar. They come directly to me. And the other thing is you can email us at info at 3hti.com. Or you can call us at 866-624-3484, I'm sorry, 3484, 866-624-3484, which is 624-3HTI. Someone said they cannot see the links.
I think you might have to post them into the chat. I'm not sure if I can post out to.
Oh, you said it. Okay, you host and panels. Okay, so hang on. So how do I do this? Just let me make this to everybody. Everyone. Here we go. Here are the links. So let me make sure I can get. So I'm also going to copy these links, and when we have the webinar recording, that'll be sent out probably tomorrow or later this afternoon. I will make sure that these links are included in the link to the recording. Awesome. Well, I want to thank everybody for being on today, and specifically also want to thank Paul for doing such a great job and helping us out every week. Thank you, everyone. We appreciate it, and have a great week, great weekend, and we'll hopefully see you next Thursday for our next webinar. Take care, everyone.